Hello everyone, very good afternoon to all of you. Welcome to IMS Gate Academy. In this session we are going to discuss about Gate 24 Computer Science exam analysis as well as detailed solution. So student, whatever memory based questions we have collected till now from the students, now we are going to provide you the detailed solution of those questions. But before that we will discuss about the pattern of question that has been asked in today's exam. So today is 10th of Feb and exam conducted at 9:30 to 12:30 and now around 1 p.m. we are live here. So just confirm audio and video guys, yes. So student, if I talk about the subject wise weightage from the last 5 years, 2019, 20, 21, 22, 23. So here you can say that the subject wise weightage of each subject. If you talk about general aptitude, generally it is fixed to 15 marks. C and data structure, general weightage vary from 10 to 12 marks. Database management, DBMS weightage vary between 5 to 8 marks. TOC subject varies between 8 to 11. Operating system weightage vary between 7 to 10 marks. Digital logic subject weightage varies even here 2 to 6 marks. Algorithm weightage varies between 2 to 9 marks. Engineering mathematics, because you know that in the computer science, engineering mathematics only 3 topics are there. Mathematics, engineering mathematics mein first is linear algebra, second is calculus and probability. So that is why the weightage is around 8 to 11 marks. Discrete maths weightage around 6 to 12 marks. COA weightage around 3 to 11 marks. And computer network weightage around 8 to 10 marks. Similarly, CD weightage is around 6 to 8 marks. So these are the general weightage subject wise as far as last 5 year gate papers are concerned. Now if I talk about the pattern of question that has been asked in the last 3 years from 20, 21, 22, 23, even last 4 years. So if you will focus on the last gate 23 data analysis, so multiple question MCQ was 34, MSQ multiple select questions was 15. It is a very good number guys. Generally we have seen in the other branches like civil and mechanical, generally 4 to 5 or 6 to 7 MSQ maximum has been asked. But here 15 MSQ was asked in gate 23 exam as far as computer science is concerned, and numeric NIT questions was 16. So now we talk about this gate 24. Now we are talking about computer science forenoon session paper analysis, where this is the complete subject weightage, my dear student. Engineering mathematics weightage 8 marks in today's exam 10th Feb morning 9:30 to 12:30. General aptitude of course 15 marks weightage. C programming data structure 8 marks weightage. Compiler design 8 marks weightage. TOC subject 7 marks weightage. DBMS 8 marks weightage. Digital logic 5 marks. DMGT 5 marks. Operating system 10 marks. COA 9 marks. Computer network 9 marks and algorithm again 8 marks. So this is the complete subject wise weightage for gate 24 computer science forenoon session exam. Now if I talk about the pattern of question that has been asked in today's exam gate 24 computer science forenoon session, MCQ 29, NAT 16 and very important MSQ star mark, my dear student. In the last weekend 3rd and 4th Feb also we have did the exam analysis for data analysis and artificial intelligence as well as mechanical, civil and instrumentation, and we have seen the maximum number of MSQ was only 5 to 8, but this time the maximum number of MSQ has been asked in the computer science exam. Of course we have an advantage because in MSQ and NAT we don't have a negative marking, but the confusing part is in the MSQ we have a multiple select question, so it is little bit tough to comment on the correct answers and all. So definitely guys, negative marking, no negative marking in MSQ and NAT. MCQ of course we have a negative marking. So now student, I would like to invite our next faculty member, Shri Harsha. So he will come and he will solve some memory based question, some questions we just got from our student side. So whatever questions we have collected till now, we are providing you the detailed solution. But before that, I want that you everyone should share the session so that maximum student can get benefited from these live analysis and paper solution sessions. Okay. So guys, just allow me for the 1 minute, or next faculty members are about to come.
Good morning, students. So we have a question from data structures here. So the question is given like this. So we have an array of elements 82, 101, 90, 11, 111, 75, 33, 131, 44 and 93. So this is the array given to us, and the question is, when we heapify this array, what are the top 3 elements that we get? So the options are given like this: 131, 11, 93. Second option is 131, 111, 90. Option C, we have 82, 11, 83. Option D, sorry, this is 93. And then we have 82, 90 and 101. So let's make this 93. Yeah. So now let us first try to heapify the given array. So how do we do that? First, you construct a complete binary tree with the elements given in the array. So we have 82 here. In the next 11, I'm sorry. This. Yeah. In the second level, because we have to start filling from the left, so let us fill this 101 and then 90. And then again start filling from the left and go towards right in this level also. So again, in every level we will be filling from left to right because this is complete binary tree. So now, this is 33. Now let us start our heapification. So how do we do that? we will start with the last non-leaf node. We'll start with the last non-leaf node and we go backwards. So let us first compare the child here with the parent. So the parent is already greater than the child, so we leave it as it is. So we are doing a max heap here. From the options, you can make out that we have the maximum elements. So the question is about max heap. So now the next non-leaf node is this one, 11. So we should heapify here. So how do you do that? First you compare these two children and the larger one you compare with the parent. So 131 is greater than 11, so it should be the parent. So 131 comes here, whereas 11 it goes here, right? And then next non-leaf node is 90. So let us heapify here. So we have two children here, 75 and 33. The larger one among children is 75. Therefore, now we compare with the 75 with 90. So if you see here, 90 is the greater element and it is already the parent. So it is already in max heap form. Now come to 101 because it is the next last non-leaf node. Now you see here the children are 131 and 111. So among 131 and 111 the greater element is 131. Therefore we compare this 131 with the parent. So we observe that 131 is greater, therefore it should be the parent. So we swap. So 131 comes here and 101 goes below, right? And finally we heapify the root here. So let us take these two children, 131 and 90. 131 is the greater element. This you compare with the parent. So 131 and 82. 131 should be the parent. Therefore 131 comes here and this 82 comes here. So what are the top three elements that we got here? 131. I'm sorry, one more thing. So once we do this, we should also check the levels below it. We should recursively check. So again check here. So 82, is it greater than both of his children? No. So swap with the greater children. So 111 comes here and 82 comes here. So further we will swap this 82 with 93. 93 comes here and 82 comes here. So this forms our max heap, right? So we see that the top three elements are 131, 111 and 90. So option B is our correct answer. Option B is our correct answer. So let us go with another question, next question, which is from databases. Yes. So let us see the next question. So we are given two relations, relation R which has A and B, and relation S which has A and C. So now R is given like this. So we have a table R. So 10, 20, 20, 30, 30, 40, 30, 50, and then 50 and 95. We also have S. S has 3 rows. So these are the relations that are given to us. So what is the question? The question is we need to find out the number of tuples in the expression, like given by the expression So we will select with the condition B less than C from R join with S the equality on column A. So R dot A is equated to S dot A. So how many tuples do we get? So let us do these steps one by one. So first R is joined with S. So we have to compare the A column in R and A column in S. So we get a match here. So 10 and 10. So we will get one row from here. And then we have R dot A value 20, but we do not find any 20 here in the S. Now let us see the next value 30. So again there is a match here in the S table. Similarly, there is a 30 here which also matches with S dot A value here. And then we have 50, there is no S dot A which is 50 here. So now what is the result that we get when we join R and S? So these are the columns that we get. So A, B and C. So first row is 10 in A and then 20 in B and then we get 30 in C. So this is one row and then we have 30 and 40 and 45. Finally we have 30 and then we have 50 and then 45. So now after this, let us apply this condition here. We need to select the rows where B value is less than C. So where do we have B less than C? So let us check here. Here this 20, it is less than 30. So this is a match here. And then 40 is less than 45. This is a match. Whereas in the last column, we have B value 50, which is not less than the C value, which is 45. So this tuple is not selected. So therefore, how many tuples do we get in the result? When you choose like this, we will get 2 tuples. So this is the answer. We then have a question from computer networks. So let us solve this question from computer networks. It is asked from TCP connection establishment, 3-way handshaking. So the question is like this. So a TCP client P is establishing connection with Q. The TCP server Q. So now it is given that NP is the sequence number in the SYN packet that is sent from P to Q, and NQ is the acknowledgement number in the SYN plus acknowledgement packet that is received by P from Q. So now we are given 3 options and we need to select, we are given 4 options. We need to select what are the true statements among them. So first one says NP is always 0 for every new connection. Second option says NP is equal to, or rather NQ. So option C says NP is chosen randomly by P. And option D, it says NQ is given by NP plus 1. Let's fix this. Okay. So let us analyze this. In TCP, you know that for a connection establishment, there is a three-way handshaking protocol. So initially, the client P, it will send a packet, SYN packet. In reply, Q will send SYN plus acknowledgement. At the end, there will be acknowledgement packet. So now they are saying on the SYN packet, the sequence number is NP. When Q receives the SYN packet with sequence number NP successfully, it will ask for the next packet. Because it received the sequence number NP, so next one that is expected by Q is NP plus 1. Therefore, when it sends acknowledgement, it will ask for NP plus 1. So acknowledgement is always the next expected packet number. So NP plus 1 is the acknowledgement on SYN plus acknowledgement packet. Therefore, we have NQ equal to NP plus 1. This is the one correct option. Besides, we also need to remember that in a TCP connection establishment, we always start with a random sequence number. So option C is also correct. NP is chosen randomly by TCP client P. So we have option C and option D as correct answers here. Let us go with the next question. So we have a question from operating systems. So we are given 512 GB hard disk. Now it is also given that the hard disk has 32 surfaces, 4096 sectors per track and 1024 bytes per sector. This is the data given, and we need to find out the number of cylinders in this hard disk. We need to find out the number of cylinders. So what do we know? So let us say we have a hard disk here. We have multiple platters, right? And these platters, they are divided into tracks. And these tracks together on all platters, we call it as cylinder. So how do we know the storage capacity of hard disk? The storage capacity is given by the total number of surfaces like this it should be multiplied with each surface is divided into tracks, right? And like track 0 on each surface forms cylinder 0. Track 1 on each surface together forms cylinder 1. Therefore, when we say number of tracks, it is equal to number of cylinders. We multiply number of surfaces with number of tracks, which is same as number of cylinders, which we need to find out. Let us call it x. This multiplied with each track is again divided into sectors, right? So to get the capacity, we take number of surfaces, we multiply that with number of tracks, and each track is further divided into many sectors. Therefore, we multiply with number of sectors per track. And finally, now we know how many sectors are there. We multiply that with how many bytes are there in each data, in each sector. Now just substitute all the values in this formula, you will get your answer. So now this is nothing but 512 GB is equal to number of surfaces, which is 32, into x, which is number of cylinders that we are trying to find out. It is to be multiplied with number of sectors, that is 4096, which is again multiplied with number of bytes in each sector, that is 1024. So now we know these values here. 512 is 2 power 9, is to be multiplied with GB. 1 GB is 2 raised to 30 bytes. This is equal to 32 is 2 power 5 into x. 4096 is how much? 2 power 12, and this is 2 power 10. So now we can calculate our x value. So it is 2 power 39 bytes divided by 2 power 5 into 2 power 12 into 2 power 10. So what is this? 5 plus 12, 17 plus 10, 27. So 2 power 27 bytes. So what do we get here? It is 2 power 12. So there are 2 power 12, which is nothing but 4096. These many cylinders are there in the given hard disk. There are total 4096 cylinders in the given hard disk. So this is a straightforward question. It is just the application of formula that we know. So next, let us see an aptitude question. One minute. Let us continue with the aptitude question that we have here. So we are given logarithm of p square plus q square is log p plus log q plus 2 into log 3. So now we need to find out the value of p raised to 4 plus q raised to 4 divided by p square q square. Okay. So now let us work on the given statement. So we have log of p square plus q square. On the right side we have log p plus log q, and this can be written as log of 3 square. So now we know that when we have like addition of two logarithms, so what we can apply the identity here, right? Log x plus log y is log xy. So this is log pq plus this is log 9. On left hand side we have log of p square plus q square. We bring this term to the left side, so we will have log of p square plus q square minus log pq is given by log 9. In the question we are not given what is the base of logarithm, so we do not make any assumptions unless they give. So log x minus log y is log x by y, so we apply that. Now remove the logarithm function, we get the values here. Square on both the sides. I'm sorry. What happened? This came, I don't know how. So again, so this question will be covered by Priyanka ma'am. So meanwhile, I will collect some more questions from system subjects. Okay. We'll continue.
So now guys, I am going to solve one question for digital. Thank you, Harsha sir. Okay. So just confirm audio and video guys. So just confirm audio and video. Is there perfect? Yes. So student, very soon engineering mathematics questions also income I am going to take. So no problem. So right now student, I have one question of digital that is very easy question and from multiplexer topic. So if you have attended the classes guys, this is a gift for you actually. Just confirm audio and video fast in the chat box. So what is the question guys? Subject name is digital logic. And what was the question? The question is, we have multiplexer given guys. I am just making the diagram for you. Okay, so multiplexer diagram given to you like this. 2 cross mux are given, 2 cross mux given. Okay, and all are connected like this guys. This is given to you. So let me take here list. First is this. We know that input terminal I0, I1. So I will just make the diagram for you guys, and after that we'll solve. Whatever the given data is given, I'm again also will mention here the given data. Okay, so this is your question where it is mentioned I0, it is I1, sometime it is I1, I0 also. So you have to be conscious about that, ki what is the input terminal. Okay, so I0, I1 given to you. Select line here A given, here also select line B given, and select line C is given here. The input terminal which is given here, this is x1, this is x2, this is x3, this is x4. So exactly whatever the given data I am just writing here, guys, and here we have the output y. And what are the given values to you? The given values are, I just make the question diagram first for you. So this will be the question box, okay, and in the question box what is given to you? So in the question, the given data, x1 value, x2 value, x3 value and x4 values are given to you. What are the x1, x2 values? x1 1, x2 1, x1 1, x2 1, x3 0, x4 0. And asking for number of combination of ABC, number of combinations of ABC for getting output y equal to 1 is. So it is, I think, NIT question. Just confirm the data also. Just confirm the data, my dear students. Chali. So student, why I told you it's an easy question, you know that is a 2 cross 1 mux, 2 cross 1 mux. As far as multiplexer working is concerned, you know that many input, one output. So we have the data input, we have select input. This is called data input, this is called select input, and you know how to start the working. So if I want to write the output of this, I should start this A bar, I0 ke corresponding, the selection input will go as A bar. So A bar into x1 and A into x2. So if I will write even values also, so first I am writing here the output. So I am writing here this A bar into I0, A bar into even x1, I0 corresponding x1. So A bar into x1 plus A into x2 plus A into x2. And do you know the values of x1, x2? So x1, x2 is one value, sir. So if I will put eventually A bar into 1 plus A into 1. And we know the Boolean properties, A bar plus A is always 1, guys, always 1. So ultimate input at the I0 port will be 1 only. This is your input port for this third multiplexer. Similarly, student, if I will write the equation here, eventually I should write B corresponding I0 input terminal. The input will work as a B bar into x3 plus B into x4. So when you will write again x3, x4 value, because it is 0, 0. So of course something into 0 is always 0. So final value will be 0. So directly at this point you have 0. And this is also a rule, guys. If all the multiplexer inputs are same 1, 1, output should be 1. If both are 0, 0, output should be 0. Even no need of this in the examination hall. I am just writing this for you a better understanding, conventional approach. As far as GATE exam is concerned, if you have did practice for the multiplexer question, you can easily solve such type of question. Now tell me, guys, 1, 0 here. So what is the output y? If I will write the output expression y, then eventually I will get C bar into 1. I will get C bar into 1 plus C into 0. So ultimately y expression will I get C bar? Yes or no, guys? Yes, sir. Will get definitely. And student, if C bar is 1 and asking that how many combinations of ABC for getting output y1. So student, ABC combination, it means can I make a table? Yes, sir. So if I will make a table for different ABC values, let me take the truth table ABC. So ABC here. And what is my output y? My output y is equal to C bar. So if I have the value ABC here, I will consider this 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1 1 1. And do you know y equal to c bar? C bar means whenever c value is 0, 0 ka bar output will be 1. Shabash beta. Tribhuvan Kumar, you are getting correct answer. Prakhar also getting correct. Tharun, you are not correct beta. So c bar, when you just see the c bar, where is c bar means wherever c1 output 0, wherever c0 output 1. So here is 1, here is 0, here is 1, just focus on c only because depending on only c. Here is only 0, here is 1, here is 0, here is 1, here is 0. So if you want to write the when the output is 1, so correspondingly this input, this and for this input 1, this 0, and correspondingly if you want to say the output 1, so corresponding 0, then 2, then 4 and then 6. So how many combinations we have? All the right you have to count 4 combination. So final answer for this question is 4 only. Even you can also write like this, y equal to c bar is equal to sigma m. If you want to write in form of sigma m also, you can write 0 2, you can write 0 2, 0 2 this is 4, 0 2 4 and 6, 0 2. So this will be your final answer guys, asking for the combinations of 4 combination. So very easy question, I must say that, very easy question, scoring question, and you can easily solve this question. Just do reply pyare bachcho, is this clear or not? Just do reply guys, is it clear or not? So now we'll start with maths and aptitude. So student, just confirm this. Just confirm the data of some more questions about to come, COA, TOC, data structure, DBMS, okay. So stay tuned, and today evening also we will be live guys, okay. We have the paper from 2:30 to 5:30. So after 5:30 even one of our mentor, that is Mr. Ravi Kumar, has also already went for to write the GATE exam only. So he is also appeared for the GATE exam to collect the memory based questions or to have the experience for the difficulty level of computer science paper 2 afternoon session, okay. बुला दो भाई. Okay guys, so next we'll start with engineering maths and aptitude.
Hello everyone, welcome to all of you. So please guys confirm first of all audio video is clear or not. I hope both are clear, audio and video. Yes. Okay. So we are going to deal here with the questions of general aptitude and engineering mathematics. I hope you guys did well, because till now the results which I am achieving or which I am response I am getting from the students, they are saying that the maths and aptitude was easy. Maths was easy and aptitude we can say was in moderate level of. So let's approach with the question. I am having first question from the engineering mathematics. Let's see, because now what we can see, we are having the same pattern. In the last weekend also we are having question from the linear algebra, eigenvalue in all the branches. This weekend also in the CS first we are having question from the eigenvalue. So this is a very common thing which if a student is going to appear for the EE and EC in the tomorrow and even in the afternoon slot also, so they need to be very well prepared with the linear algebra, which is very common, okay, which is very important also. So let's start with the one very simple question of the product of eigenvalues. So question is talking about product of eigenvalues for the given matrix. The matrix for the given matrix A, that is 1 2 3 4 5 6, okay, and the next is 7 7 8 9. Actually we can approach this question with the multiple methods, and we are having options also. I will show you here. We are having options, that is 1 2 -1 and 0. If we want to go with this one, now we can approach the question with the multiple methods. I will tell you here 3 or 4 methods, very easily we can understand. But the one very simple thing, if a student learn from me without using pen, you can solve this question. Without using pen, yes, you can solve this question. Why? Because we learn the simple concept ki whenever in a matrix, whenever in a square matrix, elements are in a continuous form. You can see elements are in the continuous form 1 2 3 4 5 6 7 8 9. If all the elements mentioned in one row, first row, second row and third row, if all the elements are consecutive, then the determinant will be 0 every time. Every time your determinant will be 0, you can use this concept. You can just go with this simple concept also, okay, right. So first of all, very easily I will, as I told you, without using pen I can write down, because you are asking me about the product of eigenvalue, and product of eigenvalue is nothing but the determinant only. So if you want to solve this question, then by the key point which we used to learn in our classroom, I will solve this question by the keynote, that whenever we are having a matrix in which all the elements are in a consecutive manner, in a continuous manner, then means 1 2 3 4 5 6 7 8 9 10 11, like this one. So the determinant will be 0 every time. So in that one we can write down the determinant is 0 for the consecutive numbers, for the consecutive numbers in rows or column, whatever the pattern you are following. If you are following with the row or you are following with the column, then also you can solve. So first directly we can approach that when the determinant is 0, it means the product of eigenvalues is 0. So hence my answer will be 0. I can go with this one. Suppose a student want to go with no ma'am, suppose I just forgot this keynote, then what I need to do? Okay, don't worry, we are having the second option also. So this was my first method. Let's go with the second method. The second method is, if you know, we in each and every question of linear algebra, wherever the matrix is given to us, we used to go with the same approach. So what is the question? I am writing here the question for you: 1 2 3 4 5 6 and 7 8 9. So we know this thing, whenever the very first element is 1, this is again our keynote in the classroom. So whenever the very first element is 1, we need to make it all the elements below this 1 equals to 0. So if you want to go with the row transformation, then also you can solve R2 minus 4R1, and when you will go here R3, at the place of R3 you should write down R3 minus 7R1. When you will follow this one, so in this case your matrix I'm writing now in the determinate form, because I will very easily write down this one. So 1, 2, 3, this is our basic approach for each and every question of the rank, each and every question of determinate, each and every question of the system of equation including eigenvalue. We can just approach it. So 1, 2, 3, when I will go 4 minus 4, it will become 0. When I will go 5 minus 8, so it will be minus 3. When I will go with 6 minus 12, so it will be minus 6. So similarly 7 minus 7, 0. When you will go with this one, 8 minus 14, so it should be minus 6 here, and when you will go with this one, it should be minus 12. Again I can see the determinant is 0. If you think यार मैम अभी तो नहीं दिख रहा है determinant 0, तो अभी दिखने लगेगा. When from the second row you will take minus 3 common, when from the third row you will take minus 6 common, so it will become 1, 2, it will also become 1, 2, and we know very first property of the determinant which we used to discuss, that if in a matrix any two rows or columns are identical, तो determinant को आंख बंद करके 0 लगा दो. ये determinant बन गया आंख बंद करके 0. When the determinant is 0, अरे भाई determinant is nothing but product of eigenvalues only ना. So product of eigenvalue is equals to 0 because my determinant is 0. Second method. Third method, if you want to approach ki no ma'am, I also don't want to go with this one, then what to do? Okay bhai, if you don't want to go with this one, then directly find out the determinant and your answer will be there. This is the third approach. So if you don't want to go with any of these two, then you can go with the directly, you can write down when you will find out the determinant directly means 1 with respect to this one, 2 respect to this one, 3 respect to this one, then also determinant is 0. The fourth method also we are having for this question. What it is? We are having the determinant here, means we need to find out the determinant. So I am writing in the form of the determinant again. So if you want to solve this question again without using pen, without using pen, means by the observation again we can solve this question. How? We can see we are having first row, second row and the third row. Now look at here, R1 and R3. We are having 7 plus 1, 8 here. Okay, I am writing here what is R1 plus R3. So that is 8. And when I am looking to the R2, that is twice of the R2. So means twice of this one. So this is nothing but twice of R2. So we are having any relation, we are having dependency, and whenever in a matrix any one or means more than 1 or 2 rows are dependent, the determinant will become 0 directly. So by the dependency also you can say the determinant is 0. So this will be twice of 4, that is 8. Similarly when you will check, this is 10, twice of 5, that is 10. This is 12, twice of 6, that is 12. So here also it will become, this also you can use, and in this case also your determinant will become 0. So ultimately your determinant is 0, means your product of eigenvalues will be 0. Very easily, very simply we can approach it. Alright. So I hope you guys are very comfortable with this one. Okay, so now one question I am having from the median of the series. So let's come to the next question. You guys can also confirm the data, and thanks to the Nitin, the student, share me the question. So if you guys are having the question, then you guys can also share us okay, through the Telegram also. Even if you want, you can just write down the question in the chat box also, so that we will just try to solve the questions in front of you. Chalo, let's go with the question. I am approaching this question. So this question is from the general aptitude. So the question was about the simple question from the, you can very easily you can solve. Find the median of the given series. Find the median of the given series. Okay. If you prepare very well in the maths states, then also you can approach. If you know the basic of states class 10th 11th, then also you can solve this question. We are having a series and we need to find out the median of this of the given series or the sequence. So the sequence was written like this one. Maybe as I told you, these questions are the memory based question. Maybe the sequence which I am writing is not exactly correct, but the answer ultimately the approach will be the same here. So the sequence will be 9, 10, 14, 15, okay, 11, 17, again 11, 18, 13 and 69. This was given to us and we need to find out the median in this case. So let's approach for the median. How to do? So very easily we can go for the median. Yeah, let's approach for the median. So how to do? Very easily, we know very well. Let's count first of all how many numbers we are having here. 1 2 3 4 5 6 7 8 9 10. So whenever we know this one, if your n is even, means total number of elements are even in any given series, and we need to find out the median. So we know very well in this case the formula of median is nothing but n by 2th term, average of n by 2th term plus n by 2th plus first term, means n by 2 plus 1th term, n by 2th term plus n by 2th plus 1th terms average. So if I'm looking, I will not approach it directly. I need to just rearrange the given series in a systematic manner. So when I will rearrange this one, it should be 9. If I'm talking about the question, it should be 9, then it is 10. Okay, increasing order 9, 10, then we will go for 11, 11, 11. The next is 11. We are having after that 13 also. The next is 14. The next is 15. The next is 17. The next is 18, and I think after that we are having 69 only. So we can cross check. Had we write down all the 10, 1 2 3 4 5 6 7 8 9 and 10. Yes, exactly. So what will be the median in this case? So my median will be n by 2, means 10 by 2th term. 10 by 2th term means actually the 5th term. Okay, and the next will be 10 by 2th term plus 1, means the 5 plus 1, 6th term, the average. So when you will look at here, the 5th term, 1 2 3 4 5 is the 5th term, this is the 6th term. When I will go for the 13 plus 14 by 2, so the average of 13 plus 14 by 2 will be 13.5. So your median should be 13.5 in this case. Your median should be 13.5 in this case. Very simply we can approach it. So you guys can confirm also the data. All right. Now one more question I'm having from this was also from the engineering mathematics. Okay. This was also the first one was also from engineering mathematics. And one more question I'm having from the mathematics, that is the probability question. The similar pattern of question already has been asked in the GATE exam. The similar pattern I'm saying, only the data value has been changed. Earlier also in a question that was written ki we are having few number of balls, two different color of ball. If the first drawn ball is red color, then find the second drawn ball is also red. So the same pattern of question has been asked this year also. Alright, so I am writing the question. You guys can confirm about the data, and let me write down the question. The question was, the exact language was this one. A bag contains what it is, 10 red ball and 15 blue balls. 2 balls. The similar language pattern of question, similar language, and what I am saying exactly same. If you did the PYQs very well now, then very easily you can approach this question. Only and only the data value has been changed, otherwise the question has been same. So 2 balls are picked, which we used to solve in our classroom also so many times. So red balls, 15 blue balls, okay, and 2 balls are picked. 2 balls are picked at a random. 2 balls are picked at random. What is the probability, or find the probability picking both red balls, what is the probability, or find the probability of picking both red balls given that first one is red already. So when first one is red na, so you can solve again this question with the with the base theorem also, but there is no need. We can approach the question directly. You are saying that here we are having different cases. Okay, I will write down the data also here. So if we are talking about the different cases, very easily we can just go for the question. So the question is asking about, we are having 10. Let's approach the solution here. We are having in a bag 10 red and how many? 15 blue balls. So 10 red and 15 blue ball. As it is already given to you, the first one, in the first draw, the ball you draw or the ball you find out that was red already. So if you still want to go in this case, I will tell you both the approaches, but as I will prefer the easier manner, and the question which has been asked in the GATE exam earlier, that also we used to solve by the simple method. So when it is mentioned already that the first draw is red, so here I am having red only. In the first draw I am having red only. If I am talking about in the first draw, we are having already red. So now you are asking about in the second draw, you want red again. So if you want to go in when the first draw already red, okay, so I need to find out the probability. So in the second draw you want red either from this one or this one. Ultimately the approach will be same. So your required probability will be, you are having total 10 red balls, okay, and here we are having 15 balls. Okay, one ball you already draw. One ball which you already draw is red simply. So now you want to draw the second one, and second one also you want that is red. So first we already completed red, and the second also we want to get a red ball, another red one. So we know when in this question replacement is allowed, not mention, and whenever in the question replacement is not allowed mention, it means here it's not mentioned na ki replacement is allowed or not. So it means this is the case of without replacement. Very clearly we can understand when it is not mentioned specifically ki replacement is allowed or not. So this is the general case, this is the normal case of without replacement. So when the case is of the without replacement, so definitely when you already draw one red ball, total you are having earlier 25, and you want to find out in the second draw also the red ball. So I will go directly for the probability of getting red in the second one. I will not talk about the first one because first is already done here. So when I will go for this one, so now I am having remaining 9 balls are there in the box. Out of those 9, you want red. So it should be 9C1 divided by, in the box earlier total 25 items or 25 balls were there. Now in the box 24 balls are remaining because one you already draw. So which you already draw, this task is done. I am talking about this second one. So this will be remaining 24C1. So 9C1 by 24C1 is 9 by 24. 9 by 24 when you will solve, it will be 3 by 8 and it will give you 0.375. So I think this was a NIT question and very easily you can write down the result 0.375. Okay, clear? I hope this is clear. Very simply we can approach. Okay, if a student wants to do, no ma'am, I want to do with the basic, means with the conventional approach, this is the easier one. Still if you want to go with the second approach, so I am writing that approach also in front of you. Very easily we can approach. We are having 10 red and we are having 15 blue balls. So you want 15 blue. So you want, the first is already red as it is mentioned. So first we already taken as in red. Now among this one, what is the possibility? The possibility I can get the red ball also, the possibility I can get the blue ball also, but actually my requirement is red ball only. So in this case I am writing in the first draw and this is the second draw. In the first draw you already completed the red ball. So if you want to go for the total possible cases, if you want to go in this case with the total possible cases, so what should be your total possible cases? Means if you want to find out ultimately what is your requirement. So we can say how we reached up to the second experiment or the second row, how we reach. We need to draw first of all the one red ball, then we reach to the second as a red, or we should have first red and second blue. I will come to the requirement also, but I am writing right now the total possible cases. It is possible either both should be red, or it is possible first draw is red and the second draw is blue, right? If I am talking about total, what is the total probability reaching up to the second draw? This is my total probability or the total possible cases. So if you will go with this one, the probability of getting red in this case will be, as I told you, the 10 by 25. Okay, in this case also this is the 10 by 25. This will be one you already draw, so it will be 9 by 24. Okay, and if you want to go with this one, this will be 15 by 24. You can, if you want, you can cancel out and you can simplify also. So when I will go with this one, red or red blue, these are my total possible cases. But what is my requirement? My requirement is I want both as a red. So my favorable will be both red. Now this will be my favorable, right? And we know very well the probability is nothing but favorable by total. So if I want to go in this manner, favorable is I want both red. So bhaiya both red divided by total probability, or is denoting plus. So probability of getting red, probability of getting red, or probability of getting red blue. This is your total probability, right? So when you will approach it, so here probability of getting red, as I already write down, so you can write down the result 10 by 25. Okay, and again the red is 9 by 24 divided by 10 by 25 into 9 by 24 plus 10 by 25 into 15 by 24. So if you will solve in this case, I can say 10 by 10 by 10 by 25 gone, 24 gone. So I am having actually 9 by 24, which is nothing but 3 by 8, which is nothing but 0.375. So in this case also you will have the same answer. But there is no need to use this method in this sense. Why? Because it will be a lengthy thing and maybe you will confuse also. So very easily still you can approach this process also we did in the classroom, and this is the easier one which you used to approach in the classroom. Okay ji? So these are the two. One more I am having from the general aptitude. One question I am having from the general aptitude. Let's approach that question. The basic question from the logarithm. Okay, the question is talking about if log of p square plus q square equals to log of p plus log of q plus twice log of 3. All right, and I think we are having options also. So then we need to find out the value, then find the value of p power 4 q power 4 divided by p square q square. We need to find out this value, and we are having options also. Very easily within 2-3 lines we can solve this question. 83, 81, 79, and the next one is the 9 only. Let's approach it. So how to go with this one? How to approach? So very easily we can go with this question, although I can go with the multiple method, but I will prefer here to go with the easier manner. Okay, so very easily we can go with the question what is given to us. Let's start writing from this one. From the basic logarithm property we can solve this question. Log of p square q square equals to log of p plus log of q plus log of 2 power 3 means 2 log 3. I want to write down this as in 3 square. So it will be log of pq plus log of 9, okay, and it will be log of p square plus q square. When I will approach, I can see here log of p square plus q square equals to, again I will go with log m plus log n. What I did here, log m plus log n is log mn only. When I will use it again, so this is log of pq, that is log of 9. Here again we can use the log m plus log n, which will be, you can write down log of 9pq. Here we can see the base is same, so the log will be gone. So directly I can write down p square q square is equals to 9pq. P square q square equals to 9pq we are having. So we need to find out the value of p power 4 plus q power 4. So I need to go for the squaring both the sides. When I will go for the squaring both the sides, so it should be p square plus q square whole square equals to 9pq whole square, a plus b whole square. a square plus b square plus 2ab we can approach. So when I will go, this should be p power 4 q power 4 plus 2p square q square, and 9 square is 81, that is p square q square. I can see these two things are same, so just shift there also. So p power 4 q power 4, 81 minus 2 is 79, p square q square. But actually I am looking for the value of p power 4 plus q power 4 divided by p square q square. So bhaiya, this is not required, let's shift it here. So when we will shift it, it will be p power 4 q power 4 by p square q square equals to 79. So your answer should be 7979, dear students, which we can see in option C for Chennai according to me. Means the sequence of the options can be changed from your side also, but this is according to me, and very easily we can just go for it. Okay. So till now I am having these questions only. I am finding the more questions, as I told you. If you guys having the question, if you guys can remember the questions with the exact data value or even with the approximate data value, you can send the question directly to us through the Telegram. And even if you want, you can write down in the comment box also, so that we will get to know, okay, these are the questions, and we will try to give you the solution as early as possible. Alright, so till now maths and aptitude questions, these whatever I just solved, these I am having. I will go for the more questions. Till that you guys can continue with the other technical subjects also on this YouTube channel only. So stay connected, we are going to continue with the other technical subjects also. So just stay connected here.
Hello everyone, welcome back to IMS Gate Academy. Here I think mathematics and aptitude questions you have solved. Before that I have already solved one digital question, very easy question. I have one more question from digital logic, and it is a MSQ. So first of all, just confirm audio and video beta. I think perfect, yes. So I have one more question for you. The subject is again digital logic, very easy question. So what is the question, guys? And it is a MSQ. It is a MSQ. So choose the correct options. I am writing the question first of all. Question data I am writing in a box, okay. I am just making a box here, and in this box only I will write the question data, and we will solve the solution part there, okay. Even I need to make this big, yes. So what is the question given to us? Choose the correct option. Choose the correct options regarding the Boolean function fxy z. And student, if you have attended my classes, then this is a short trick even 3, 5, 6, 7. I hope you remember. In terms of ABCD, if you remember, then it is nothing but AB, BC, CA, because it is nothing but the carry expression from the full adder. I hope you remember the sum expression and carry expression. Sum is A XOR B XOR C, and carry expression is AB plus BC plus CA. In terms of XYZ, it should be XY plus YZ plus ZX. Now student, options are given to you, okay. I am just writing the options here. A, B, C, D options are there, and you have to comment on the. So it is a MSQ, by the way, okay, it is given. So I am writing here f x y z. So first given is xy plus yz plus zx. And if you remember the 3, 5, 6, 7 is equal to AB plus BC plus CA, or xy plus yz plus zx, then option number A for sure correct. Option number A for sure correct. Tell me yes or no, guys. XYZ is also given in the form of pi m, and it will be 0, 1, 2, 4 given to you. The third is given to you minimum function of fxyz is independent to x, and similarly here it is independent to y, Yeah. So student, as I told you already, no need of even K-map, no need of K-map. Why no need, guys? Because in the solution, I hope you remember, this is the standard form. If you remember the full adder expression, if you remember the full adder, sum expression and carry expression, sum and carry expression, if you remember, then sum expression is nothing but x XOR y XOR z, and carry expression is nothing but what, guys? X y plus yz plus zx. And do you know it's sigma m form? So sigma m form, we know that 1 2 4 7. And do you know its sigma form? Sigma m form is nothing but 3 5 6 7. So for sure 3 5 6 7 is equivalent to xy plus yz plus zx. So it means option number A is for sure correct. Option number A is for sure correct. And if you feel that, if you know that ki carry expression xy plus yz plus zx, so tell me, it is the only minimized expression, xy plus yz plus zx is the minimized expression only. Even K-map is not required, still you want to make K-map, you can make it. You can make the K-map as well. You can make the K-map as well. But it is actually not required. Okay. Okay. Let me take again pen only. Yes. So, here tell me, if I will make K-map again, if I will make K-map, then what I will get? K-map, however, not required here. If you are doing the K-map, you are just wasting the time. Because a smart student can easily solve this question without using K-map. So, this is x, y, z. And given to you 3, 5, 6, 7, you know that it is 0, 1, 2, 3. Whatever I am doing, it is redundant for GATE. In the GATE exam, you should not do like this. You should remember the standard form. You should remember the standard form. Tell me yes or no, guys. Just confirm audio and video first. Chali. So 3, 5, 6, 7. Here is 3, here is 5, here is 6, here is 7. So if you will make the partition, if you will make, so here it will be x bar, here it will be x, it will be y bar, z bar, y z, y bar z, y z and y z bar. So what you will get? You will get here y z, you will get here x z, and you will get from here x y. So same to same expression you are getting. So it is the only minimized expression, and you know that minimized expression containing x value also, y value also, z value also. So it is depending on x, y, z. So it means option number C and D for sure wrong, because it is asking for it is independent to x or y. No, it is dependent to x, y, z, all the three parameters it is depending. And do you know if sigma m is this, if sigma m is this 3, 5, 6, 7, if you want to write in equivalent POS form, then POS form is whatever data is missing here, you can write here. So 0, 1, 2, 3 is missing. So pi 0, 1, 2, 3. It is pi 0, 1, 2, 3, I think. It is pi 2, 0, 1, 2, 4 actually, yes. So pi 3 is there, so here, sorry. 3 is there, na? So 0, 1, 2, 4. 0, 1, 2, 4 is missing. 0, 1, 2, 4 is missing. So 0, 1, 2, 4 should be in the pi. So 0, 1, 2, 4 is there, so it is also correct. It means A and B options, both options are correct, and it is because it is a MSQ question, multiple select question. And even you can fetch from here also. Here is 1, so here is 0. So you can write the pi m form also from here. It will be 0, 1, 2, 4, exactly same. However, this is not required, It is a direct. What I want from my student, you should solve this question by using the full adder concept. You need to remember the full adder carry expression as well as the sum expression. So now I would like to invite again Harsha sir. He will solve some questions. So we have some more questions from your technical core subject from computer science, guys. Okay, and stay tuned on the IMS Gate Academy, because here we are solving more questions from aptitude also, from maths also, from the technical subjects also, like DBMS data structures and all. So yes, Harsha sir, please come. So just tell me how many subjects questions you have now more. I think you already solved some questions of data structures and all.
Yes, I have like 2 more questions from data structures, couple of questions from OS, and 1 question from computer networks.
Okay. So please confirm the audio of Harsha sir. Harsha sir, you can please go ahead. I will just add a blank slide for you. Okay.
Yeah.
On it is.
So let us first see a question from computer networks. So this is from the topic of TCP. So the question is like this: which of the following fields in the IPv4 header, so it's not TCP, it is IP protocol question, could be modified during transit. So this question has been asked multiple times in previous GATE exams also. The options given are like this. So we are having header checksum, option B is source IP, option C destination IP address, and option D total length field. Right? So we know that in IP datagrams, on the way fragmentation can happen, right? If the packet moves from a network with higher MTU, that is maximum transmission unit, into a network with lower MTU, then the given IP datagram is fragmented into multiple fragments. So when you do that, some fields will change. So what are those? Your fragmentation offset will change, and obviously your total length will change because the bigger datagram is being fragmented into smaller datagrams. So the total length field will also change. And when you change some of the fields, obviously you need to recalculate your checksum. So any fields that are related to fragmentation can change on transit. When the fragmentation happens, these fields can change. Besides, the TTL field, time to leave, also can change. Among the options, option A and D are the correct answers. So the header checksum and total length, these two fields can change during transit from source to destination in a IPv4 header. So the source IP address and destination IP address remain same. Let us go to the next question. So here we have a question from operating systems. The question is asked from the paging concept. So given a memory management system that uses page size of 2 kilobytes, and it is given that the pages 0, 1, 2, 3 are stored in the frames 1, 3, 2 and 0 respectively. Now, given virtual address 2500, we need to find out the corresponding physical address. Okay, so what are they saying? So they are saying the pages 0, 1, 2, 3 are stored in the frames 1, 3, 2, 0 respectively. So how does the page table look like? So page 0 is stored in frame number 1, page 1 is stored in frame number 3, so on and so forth. Right? So if we actually draw this memory, so let us say this is our RAM and these are our frames. So our frame 0, it will contain page number 3. So frame 1, it will actually contain, frame 1 will actually contain page 0, so on and so forth. So let us say F2, that is frame 2, frame 3, frame 4 and so on. So page 0 is in frame 1, page 1 is in frame 3. And then page 2 is in frame 2. Similarly, page 3 is in frame 0. So now they gave a virtual address 2500. So let us first figure out how many bytes are there in page, right? So the page size is how much? It is 2 kilobytes, that is 2 into 1024 bytes, or we can say it is 2048 bytes. That means each page will contain 2048 bytes. Now the address that we need is 2500. So now 2500 is given by what? It is 2048 plus 452. Right? The address needed is 2048 plus 452. So the first 2048 bytes, they are actually stored in page 0, and then we will get the offset of 452 in the page 1. So if you see here in the page 0, we have from 0th byte till 2047th byte, and then in the page 1 we have from 2048th byte till 4095th byte, right? So our required virtual address is in page 1, and what is the offset there? 452. So where is our page 1? Page 1 is in the frame 3. Page 1 is in the frame 3. So on frame 3 we need to offset 452 address. So it is frame 3 452 is the offset. So we already have, because the addresses are starting from 0 here, in frame 0, frame 1, frame 2, we already have how many addresses? 3 into 2048 bytes. These are already stored in the frames from 0 to frame 2, right? And then we need to offset 452 here. So what is the answer that you will get? So what is the answer that you will get? So it is 3 into 2048 plus 452. $6,596 is the corresponding physical address for the given virtual address. right? So let us move to the next question, so which is again from operating systems. Yeah, let us move to the next question. So this question is on threads. So identify the correct statements from the options given. So what are the options that are given to us? So option A, they are saying threads belonging to a process are by default not protected. This statement is a true statement. If we want to have protection, we need to have one more layer on the implementation of threads. In the option B, they are saying each thread has its own file descriptor. Option C, so again the second statement is false. So this statement is false. So remember that on per thread basis we store only the registers and stack. Everything else is shared, right? So because they are saying file descriptors, this can be shared. It is not like stored per each thread separately. And option C says threads can be implemented only in kernel space, which is false, because if the kernel does not support threading, we can always use user threads. We can have our own libraries. Option D says all threads belonging to a process have their own stacks. This is true. So as we discussed before, on per thread basis we have registers and stack. So stack will be separate for each thread. All other things are shared among the threads for a given process. So option A and option D are the correct answers. Option A and option D are the correct statements. So then let us solve a question from algorithms. So this question is on recurrence functions or recurrence relations. So they are giving T of n is given by root n into T of root n plus n whenever n is greater than or equal to 1. And it will end, what is the base case? Base case would be T of n equal to 2 when n is equal to 1. So this is what is given for us. We need to find out the time complexity for this equation. So let us try to use the recursion tree method. Let us try to expand the given expression. So we have T of n, root n can be written as n raised to 1 by 2 into T of n raised to 1 by 2 plus n. So now let us try to expand this term. So we have n raised to 1 by 2 outside, and then so if n is, it's like n becomes root n here, that means we are raising by the power of 1 by 2. So we do the same thing. So here we have n power 1 by 2. So same thing we raise by power of 1 by 2. So go on like that. So T of n power 1 by 2 raised to 1 by 2 again. So we'll get n power 1 by 2 square plus the same thing is carried here. So this is n power 1 by 2. So this is the expansion of T of root n term. Besides we have n already. So now let us see this. So we have the first term n raised to 1 by 2 into n raised to 1 by 2 square. So we can write this like n power 1 by 2. So the exponents will be added. So 1 by 2 square into T of n power 1 by 2 square plus n power 1 by 2 into n power 1 by 2, that is n. So we can write like this plus this outside n. So what do we have here? So n power, so you can write this as 1 minus 1 by 2 square, right? When you simplify this sum of GP expression, you will get at the end 1 minus 1 by 2 square into T of n raised to 1 by 2 square plus this will be n plus n, that is 2n. So similarly, if you want you can go to one more step also, but at the kth step it becomes n raised to 1 minus 1 by 2 power k into T of n raised to 1 divided by 2 power k plus kn. Now when does this recursion stop? The recursion stops when we hit the base case, and at the base case we have T of n is 2 when n is equal to 1. I'm sorry, it is the reverse. Inside we should get okay. So T of n is 1 when n value is 2. So let us equate like that. So n raised to 1 by 2 power k, if we equate to 2, now apply logarithm base 2 on both sides. So we'll get 1 here and then 1 by 2 power k into log n base 2. It will mean that log n is equal to 2 raised to k. Implies that, so again apply logarithm base 2 on both sides, then you will get k is log of log n with the base 2 in both places. Now you substitute this back here. So this is n divided by n power 1 by 2 power k into n power 1 by 2 power k is 2 plus k is log n into n. So this is nothing but this is n by 2 into t of 2 is 1 plus n into log n. So what is the time complexity here? So among these two terms, the second term is the bigger one. So this is our time complexity. Order of n into log n is our answer. Okay. So we have one more question from data structures. Data structure, it's like both data structures and algorithm, you can say. So given an array of size n, and we need to check if the array is sorted or not. We need to check whether the array is sorted or not. So what is the worst case time complexity? So it is a very simple and straightforward question. So to check whether an array is sorted or not, we can do one iteration of your bubble sort method, like one pass, right? You do your bubble sort for a single pass, and if you do not find any swaps, right, if there are no swaps, then you will declare that array is sorted. Right, because this is just one pass, you will be taking order of n time complexity. Right, to check if an array is sorted or not, we can use a single pass of bubble sort algorithm, and you will count how many swaps are happening. If you see that there are no swaps, then you can declare that the array is already sorted. Therefore, this step just takes order of n time complexity to pass through the array just once. Let us go to the next question from computer networks again. The next question is from computer networks. So we are given a datagram with 1400 bytes data and 20 bytes header. It passes through the networks with maximum transmission unit of 542 bytes and 360 bytes respectively, in that order. Calculate number of fragments. We need to calculate the number of fragments. That is a question. So let us solve this. So we are given a datagram with 1400 bytes of data and 20 bytes header. Now this datagram is entering a network with MTU of 542 bytes. That means in that network the maximum size of a datagram can be at most 542 bytes. Therefore what we need to do? We need to do the fragmentation here. So when we fragment, we should copy the header into the new fragment also. Therefore 20 bytes are gone for the header. So remaining, how much data can be there? Remaining you can have 542 minus 20, that is 522. But remember here, we need to have this number as a multiple of 8 because we have to store the fragmentation offset. Here 522 is not a multiple of 8, so we will go for the next smaller multiple of 8, that is 520 bytes. So we will be having 520 bytes of data. So 520 bytes here and 520 bytes in the next datagram also. So 520 and 520. So 1040 bytes of data are already covered here. So we will have 1400 minus 1040, that is 360 bytes of data remaining. Right? So this is how fragmentation happens when we enter a network with MTU 542. These fragments are further entering the network with 360 bytes MTU. Therefore, we do the same step again. So this packet here gets fragmented further. So we will still copy the 20 byte header as it is. So here 360 is the MTU. So if you subtract the 20 bytes header, we will get 340. Right? Maximum we can store up to 340 bytes provided this 340 is multiple of 8. So let us check that. So 340 check and divide by 8. So we see that 340 is not an integral multiple of 8. Therefore, we go for the next smaller integral multiple of 8, that is 336. So in each packet you can store up to 336 bytes data. So from 520 you subtract 336. So remaining is like 184 bytes. It can go here. Similarly, you will break this datagram also into 2 further fragments, and finally, so this 360 also you will break into 3 fragments. So in the first one you will have first 336 bytes of data, and remaining will fit into next fragment. So total we are getting how many fragments? 1, 2, 3, 4, 5, 6. So in total there will be 6 fragments. In total there will be 6 fragments. That is the answer. So next we'll see, let us see a question from data structures again. given a min heap with 105 distinct elements. Let K be the index of the maximum element. Sorry. The number of possible values for K is how much? That is the question. So again, this is a very simple question. So straightforward, you can just take the ceiling of the number of elements divided by 2. So this will give you the number of leaves, right? So this is nothing but 53, right? So we know that in min heap the minimum element is at the root and maximum element can be at any leaf, right? It can be at any leaf. So we just need to find out how many leaves are possible. So that many locations are possible for the index of maximum element, so which is nothing but 53. So you can also like cross check by trying to draw a tree. So in the first level you have just one node, in the next level 2 nodes, and then you will have 4 and then 18 and then 16. So until here you got, so 4 plus 3 is 7, 7 plus 8 15, 15 plus 16 31, right? In the next level you have 32, that is total 63 elements so far. So in the last level will be incomplete, so there you will be having 42 elements in the last level. So all these 42 will be leaves, right? These 42 elements are leaves. So we see that for every 2 nodes in this layer there will be a single parent above, right? So that means for these 42 leaves there will be 21 parents, right? In the previous layer 21 parents will be there for these 42 children. So what about the remaining nodes in this layer? 32 minus 21, so we have 11 more nodes, right? So they do not have children, so they will be leaves again. So total there will be 11 plus 42, that is 53 leaves. Again your maximum can be present at any of these 53 leaves. Okay, so we will continue further.
Hello students, now we are going to discuss one question which is from the subject digital logic. This is a very easy question. This question is asked from the chapter number systems and codes, and the topic is regarding 2's complement. Yeah, first I will note down the question. So in this question they have given two numbers a and b, a equal to 0 1 0 1 0 and b equal to 1 1 0 1 0. A equal to 0 1 0 1 0 and b equal to 1 1 0 1 0. Yeah, hi Pragya. Are represented in are represented in 2's complement form. These two numbers are represented in 2's complement form. Okay. In which of the following case the overflow occurs? So they have given 4 choices, you have to choose the correct one. So option A, they have mentioned addition of two numbers a and b, that is a plus b, and option B they have given a minus b, option C b minus a, and option D 2 times b. 2 times b. So this is one of the most interesting question, okay, based on the concept of overflow. Okay. So if you people remember regarding the range of the numbers regarding 2's complement form, you can easily answer this question. Okay, right. So here if you observe a and b, both the numbers are represented with the help of 5 bits. Okay, you can observe a is a 5-bit number, b is a 5-bit number. Okay, and both the numbers are represented in 2's complement form. This wording is very, very important. Okay, so first of all I am considering the range of numbers. Range of numbers in 2's complement form. Range of numbers in 2's complement form. So if you are having n bits, range of numbers in 2's complement form will be equal to, if the numbers are having n bits, okay, the range of numbers will be minus 2 power n minus 1 to plus of 2 power n minus 1 minus 1. Yeah, Saurav, for the time being, we have received the memory based question like this from our student. So accordingly, I am explaining. Okay, if there is slight change in the question, then accordingly you can choose. Okay. So just I am discussing the concept wise with respect to here. Okay, in which of the following case overflow occurs. Okay. Right. So here in this case, A is a 5-bit number and B is a 5-bit number, right? So that means n value 5 I am considering. So accordingly the range will be minus of 2 power 5 minus 1 to plus of 2 power 5 minus 1 minus 1. Okay, so from here you will get minus 2 power 4 to plus of 2 power 4 minus 1. Okay, so minus 2 power 4 is nothing but minus 16 to plus of 2 power 4 is 16, 16 minus 1 is 15. So this is the range you are going to get. This is the range you are going to get. Okay. Yeah. So minus 16 to plus 15. Okay, now let us perform in each and every case what is the corresponding equivalent number you are getting. If that equivalent number, if it falls within this range, then there is no overflow. Okay, suppose if any value, if you are getting other than this range of numbers, that means it is occurring overflow. That means whatever the number of bits you have considered 5, that with the help of 5 bits you cannot represent the resultant operation. Okay, whatever the addition or subtraction you are performing, in order to accommodate the resultant operation value, okay, because 5 bits are not sufficient. In that case, we may require one more additional bit. So that means in order to represent that one, we may require 6 bits like that. Okay, whenever we require 6 bits, that time you can say that overflow occurs. Okay. Now, for the timing, I will consider individually A number and B number. A equal to 0, 1, 0, 1, 0 and B equal to 1, 1, 0, 1, 0. Okay. So here in the question they have mentioned both A and B are represented in 2's current form. Yeah, Utsav and Saurabh, just confirm whether this question is MCQ or MSQ. Yeah, MCQ, okay. So MCQ means only one option will be correct, right? Okay, first I will discuss the complete operation. After that, you people can comment. Okay, in the given question, what they have asked. Okay, so for the time being, so just observe A and B both are represented in 2's current form. Okay, so here the moment if sign bit is 0, you can blindly follow sign magnitude context. Okay, so sign bit 0, that indicates what? Positive number. Then 1, 0, 1, 0 is nothing but 10. 1, 0, 1, 0 is nothing but 10. So that means you are getting plus 10 in the decimal form. Now here in this case, B is also represented in 2's current form. Okay, but here the sign bit is what? 1. Sign bit 1 indicates net number. Okay, sign bit 1 indicates net number. So here by using sign magnitude context, okay, by using sign extension property in 2's current form, okay, so this entire number we can consider like this, like 1, 0, 1, 0 by using sign extension property. Suppose if you consider only this 4-bit number like this, here sign bit is 1. Okay, the same sign bit we have placed one more time to the left of it, the equivalent value won't change. Okay, the equivalent value won't change. Right. So here the positional weights will be in powers of 2, 2 power 0, 2 power 1, 2 square, 2 cube. Okay, 2 power 3. Since the sign bit is 1, the corresponding positional weight is minus. Okay. So wherever ones are there, just add the respective positional weights. You will get minus 8 plus 2, which is nothing but minus 6. Minus 8 plus 2 is nothing but minus 6. Okay. So A value got plus 10, B value got minus 6. Okay. Now let us consider option A. Option A, we are having A plus B. A plus B. So A value is plus 10, A value is plus 10 and B value is minus 6. B value is minus 6. So here you are having positive number and you are having negative number, we are performing addition operation. That means actually we are performing like subtraction. Okay. So plus 10 plus of minus 6 is nothing but plus 4. So if you observe this range, within this range plus 4 is existing, right? Yeah, would so. Okay, no issue. Okay, for the timing I have considered like overflow case. Okay, whatever 4 options they have given, so let us understand in which cases overflow occurs. Okay, right. So here regarding option A, plus 4 you got here. In order to represent plus 4, we can easily represent with the help of 5 bits. There is no overflow. Okay, in this case there is no overflow. So here we can represent with the help of 5 bits. Okay, no issue at all. Regarding option B, A minus B we are having. So here A is plus 10, minus B is nothing but minus 6. So in this case minus of minus, it is plus. Okay, so plus 10 plus 6 is nothing but plus 16. Now you can observe. Here you are getting resultant answer as plus 16. Okay, but here if you observe with the help of 5 bits, we can represent the positive maximum value as plus 15, but we cannot represent plus 16 with the help of 5 bits, right? So in this case we can say that the overflow occurs. Okay, if you are considering only 5 bits, the resultant answer you cannot represent. Okay, in order to represent the valid answer, obviously we have to consider one more bit, that is nothing but 6th bit. Okay, so in this case overflow occurs. So if you want to represent the resultant sum, here we require 6 bits. Okay, so since it is a MCQ question, obviously one option will be correct. So option B is correct. Okay, now let us verify regarding option C and option D, whether those are, in those cases, whether overflow occurs or not. For understanding purpose, let us solve. Okay, further. So in option C, they have given B minus A. So B value is minus 6 minus A value is plus 10. Now here minus 6 minus 10 is nothing but minus 16. See here, with the help of 2's complement form, by using 5 bits, we can represent minus 16. Okay, minus 16 we can represent, so there is no overflow occurs. In option C case, there is no overflow occurs. Okay, and the last option, that is option D, here we are having 2 times B. Here B value is minus 6. So 2 into minus 6 is nothing but minus 12. So minus 12 is falling in this particular range only. Okay, minus 16 to plus 15, in that range you are having minus 12. We can represent with the help of 5 bits. Okay, there is no issue. So here overall, if you observe whatever the 4 choices here you are having, okay, among these 4 choices, only in option B the overflow occurs, whereas in remaining 3 options there is no overflow occurs. Okay, so the correct answer for this question is option B. Okay, I hope it is clear for everyone. Yeah, regarding EC paper, so tomorrow we are having the EC paper exam timings are 9:30 to 12:30, right? So from 1 o'clock onwards, here at our IMS Gate Academy YouTube channel, the complete detailed analysis will be there regarding EC paper. Okay, I hope it is clear for Saurabh, Utsav. Regarding this question, I hope it is clear, right? So further questions, our faculties will continue, so stay tuned.
Hello everyone, welcome back to IIMS Academy. So now I'm having a few more questions from the maths and aptitude. Let's see the solutions. So first of all, one question I'm having from the engineering mathematics. Okay, this was the fourth question, and which was the MSQ. Let's approach the question, and again you guys can also confirm about the data whether it is same or not. Okay, so the question is, if probability of A is 0.3, probability of B is 0.5, probability of A intersection B is 0.1, then which from the given statements are correct? Which of the given statements correct? We are having statements, we are having options. So have a look at the options. The first one, A and B are independent. Second one, probability of A union B is 0.7. Third one, probability of A complement union B complement is 0.4. And the last one, probability of A intersection B complement is 0.1. All right, let's approach it. So here we can go for the solution. First of all, whatever is given, we can start with that one, and along that we can start even with the options. Each and every option we can take. So what is given, I am writing here. Probability of A is 0.3. I will come to this again. Probability of B is 0.5 and intersection is 0.1. All right, so now look at here. Let's start with the options directly. We can start with the option. So let's come with the option A. Option A is saying A and B are independent. We know very well, if we are having two events and if the two events are independent, then their intersection is equals to product of their probability. So if the two events are independent, then their intersection should be probability of A into probability of B. This is the condition for the two events independent. So we can check here, if two events are independent, then it should follow, it should satisfy simply. So I can check from this one as probability of A intersection B. Let's check it out. Probability of A is 0.3, probability of B is 0.5. Okay, and already the probability of A intersection B is given to you 0.1. So when you will check, this will be 0.3 into 0.5 will be 0.15, and which is not equals to 0.1. So yes, I can say these two events are not independent. So event A and B are not independent, we can conclude this one first of all. Let's come to the option B. When I'm coming to the option B, probability of A union B is 0.7 or not. So probability of A union B, when I'm taking this 0.7. So we know very well A union B can be written as this probability of A plus probability of B minus A intersection B. So probability of A is 0.3, probability of B is 0.7, A intersection B is already given to you 0.1. So 0.8, we are having 0.3 plus 0.7 minus 0.1. And when you will solve it, the result you are having here, look at the option. In the option it is given to you A union B is equals to 0.7. No, it is not equals to 0.7. So directly if I will solve, it will not give me 0.7, it can give me 0.7 when these two values will be cancelled out. So it's not possible here. So directly I can conclude that this is also not true. So I can go with this one. This is false. The statement, okay, wait a minute, sorry. Just once again we can check what is given to us in the second option. I'm having A union B is a 0. Okay, sorry, it's my mistake. The probability of B is 0.5. Are baba, so 0.3, 0.5 minus 0.1. I write down it as a 0.7. So probability of B, it's given to me now, probability of B is 0.5. So when I will check here, this is 0.8 minus 0.1. Yes, this is giving me 0.7. So this is true. So first option was not true. So I will just cross this one. Second is true till now. As this is a MSQ, so I need to check all the 4 options. Let's come to the option C also. So when we will come to the option C is talking about A complement, right? A complement union B complement. And we need to check whether it is 0.4 or not. So we know very well AB is given to us now. So probability of A is 0.3. So from here you can write down probability of A bar means the complement is nothing but 1 minus probability of A. So it will be 1 minus 0.3, that is your 0.7. Similarly, probability of B is given to us 0.5. And again we can write down directly probability of B bar is 1 minus 0.5, that is 0.5. I need to go with this one. So when I will solve this union, so it will just open as a normal union only now. When you will open probability of A union B, it will be probability of A plus B minus A intersection B. So it will also open like this one. So probability of A union B, so it will be A bar plus B bar minus A bar intersection B bar. As the A and B are independent events, so you can write down it probability of A into B only directly. So probability of A bar is 0.7, this is 0.5 minus 0.7 into 0.5. Okay, and when I will solve this one, I am having here 0.85. So when I will solve, it will give me 0.85 and you are looking for the 0.4. So no, this is not true. So this is also false. Alright. Let's check the last option. What we are having, option D. Option D is saying probability of A intersection B bar is 0.1, and I think it will be 0.1 only. Why? Directly you can write down this thing. Why I am saying? Because now probability of A is same. This is very simple and directly you can approach. Why I am saying? Because probability of A intersection B was 0.1, and when you are looking to the probability of A intersection B complement, and that is also 0.1. Yes, it will be true. Why it is true? Because you are looking for probability of A intersection B is 0.1. When your probability of A was 0.3, probability of B was 0.5. Right now when I'm coming to this one, again I need, when I will solve this one, so what I required probability of A which is 0.3 only, probability of B complement which is 1 minus 0.5 is 0.5 only. So you can see now one very simple, the common sense we can use here, ki probability, the value, the numerical value of probability of B is 0.5 and numerical value of probability of B bar is also 0.5. So by these two are having the same numerical value. So intersection I need to do with the A only na. So A was 0.3 in this case also, 0.3 in this case also. So it will be true, 100% it will be true. So you can write down this will also true. So if you are looking for the true options, so I will go for option B and D. And still if you want to check, so when you will solve it here, when you will go for the complement na, so when you will go for the intersection A intersection B bar, which will be probability of A into probability of B bar. So when you will approach it here, yes, okay, so when you will approach it, as I told you here, directly I can approach, where is my question? Here, so I can, there is no need to solve. Even when you will solve, then also it will satisfy. So option B and D will be correct in this case. This we already solved, this is not true, or not R. You are saying if B and B are independent, this is not following, and this is also we already use in this case, and this also we solve, third option also we solve. Okay, so all the options we solved, and then we can write down the result. Alright G. Okay, and here if you want to solve, so you can solve like this also. So all the options we correct, just check here. So these three are the correct. Okay, now let's come to the next question. The remaining two questions I am having from the general aptitude. So let's check about the question. So I am having the question from the general aptitude, the very simple question from the ratio. A person has rupees 1, rupees 5 and rupees 10 denomination in ratio 5:3:13. Okay, then find the percentage of amount by rupees 5 in rupees 5 notes in the total amount. So what is the percentage amount rupees 5 is having among the total amount? Okay, let's approach. So very easily we can approach this question also. Okay, very easily we can approach with this question also, dear students. So what it is saying, we are having here three type of notes, rupees 1, rupees 5. The basic question, very simple question from the ratio proportion we can say. So ratio here it is given to you 5:3:13. Let us assume the value, I am assuming the value of rupees 1 is 5x, this should be 3x, this should be 13x. I need to find out the ratio among the total. So from the rupees 5 I need to I need to find out the percentage. How much, what is the percentage rupees 5 note having among the total? So total you are having na, so let's write down first of all the total value. So your total value will be the rupees 1 multiply with the amount of rupees 1, so 1 into 5x plus rupees 5 multiply with the amount which it is having. So we are having 3x note of rupees 5, we are having 5x note of rupees 1. Similarly we are having here 13x notes of rupees 10. So when you will go for this one, 5 plus 15 is 20, 20 plus 130, it will give you 150x directly. So this is very easily you can write down the answer even without solving from here. We are looking for the required percentage. So you can write down the required percentage is rupees 5 note, whatever we are having, the rupees 5 note is 5 into 3x, that is 15x by the total 150x, and you know very well 15x is how much percentage of 150x, so that is nothing but 10%. Very simply by just reading this one I can approach the question. So the result will be the 10%, 0 0 will be gone, 15 15 will be gone. So your answer should be 10 percentage. This is not, there is no need even to write down this one, but directly you can see here you are having the rupees 15 value is nothing but, sorry, rupees 5 note value is nothing but 15x, and your total amount value or the total value is 150x. So this is nothing but 10% of the total amount, and hence the answer will be 10%. You can approach it. All right. Now one simple question I am having from the special also. So let's see the question. So this question is from the special aptitude. The question is talking about one, let me draw. Question is talking about one straight line we are having. Okay. And here it's given to us some squares like this. Here also and here also. Sorry. Okay. In back side also we are having, this is one, this should be second. So the question is asking if the given line, or if this line is a line of symmetry, if the given line is a line of symmetry, then how many squares we need to draw around this? How many squares need to draw? We need to draw, okay, around this line of symmetry. So this is very simple question. You are looking for the line of symmetry. If this line is a symmetrical line, so around this one, when a line is a symmetrical line, so both the sides should be equal, same. So here whatever the number of square you are having this side, it should be having the same square in the another side. So let's check. When you will just go for the symmetry now, so it should be one square here we need to draw, because when I will go for the same thing means the replica of this one should be here. Replica of this one should be here. So for this I need to draw one square. So I am writing square number 1 I will draw here. The next square number 2 I will draw here, replica of this one. The next square I will draw here, replica of this one. This is 3. You can see this is the replica, this is the replica. 3. Now the next square I will draw here for the replica of this one. Next I should draw here, and the next I should draw here. So these are the 6 square which you need to draw if your given line is a symmetrical line, because symmetrical means above the symmetrical line, okay, around the symmetrical line, both the elements or whatever the elements are present, that should be the same in the number of also and the size also. So it should be same, it should be identical, same to same. So if this is your symmetrical line, so one you will draw for this one, second you will draw for this one, third you will draw for this one, fourth, fifth and sixth. So like this we need to draw how many squares? So we need to draw the 6 square. So my answer should be 6 here. Alright guys. Okay, so till now I am having these questions only, and if I will get more then I will come again live. So till that you guys can continue with the technical subjects. Those students are having tomorrow paper, they also need to consider the questions which we discussed today in the maths and aptitude, because this is common. So you need to just have a look of the, especially of the questions of the aptitude. Okay, in the maths we are having slightly difference in the syllabus, but aptitude is same to same. So you just need to go through with the questions or whatever asked in the last weekend also, and in the today also. So be aware with the content whatever we provided. Okay guys, thank you. Stay connected for the technical questions also.
So let us start. We got a question from operating systems. So this is a question on process state diagram. So the question is, which of the following state transitions are not possible? So the options that we have here are from ready state to waiting state, from running state to ready state, from running state to terminated, and the last option from waiting state to running state. Right? So we know the process state diagram, right? So from new we'll go to ready state where the processes are put in a ready queue, and when the CPU gets allocated it goes to running state. When the process finishes its execution, it will go to terminated state. In between, if there is a preemption, the process can be preempted from running state and put in the ready queue again. So this is your preemption. If the process is waiting for any event to happen or some IO, then it can also go to waiting state or blocked state. From this state, it will again, like when the event happens, when the event that the process is waiting for happens or the IO is available, it will go back to the ready queue, right? So now you can see here, so from ready, like although technically it is possible, so usually this is not a transition that we expect in the operating systems. So option A is not possible, option B is possible, so running to ready state is possible, so this is your preemption. So this is a valid transition. Running to terminated state, this is a valid transition. When the process successfully completes, it will go from running state to terminated state. And then finally, the transition from waiting to running, it is not possible, right? So for multi-programmed, like for multi-programmable computers, we will always enter the ready queue from the waiting state. So options A and C are the correct answers. We are asking which of the following state transitions are not possible. So option A and option D are the correct answers. Let us now discuss the questions from C programming. So given this code snippet, int A is 6 and int B is assigned 0. So we have a while loop. The condition A less than 10. When it is true, we execute these two statements. A is assigned A divided by 12 plus 1, and we increment A by the value of B. At the end, we print the value of A. So they are asking what is the output of this code. What is the output of this code? So let us walk through this code. So we are initializing the A value with 6 and B value with 0. Now we check the condition whether A is less than 10. So obviously 6 is less than 10, A value is 6 which is less than 10. So this is true, therefore we enter the while loop and we execute the first statement in the while loop. So which is, we will override this over A value by A by 12. A by 12 is 6 divided by 12 plus 1. So what is this? So 6 by 12 it is 0.5, but only 0 will be retained because A is a integer here. A is integer and 12 is integer. So only 0 will be retained and 0 plus 1 is 1. So A value is overwritten with 1. And then we increment A by the value of B. So B is 0. So A is incremented by 0, which leaves the A unchanged. Therefore, at the end of first iteration, A value is set to 1. So we'll check this condition again. So after the first iteration is over, we'll go back and check the condition whether A is less than 10. So it is true again because A value is 1, 1 less than 10 is true. We enter the while body of the while loop again. So A value will now become 1 by 12 plus 1. So again the first term is 0. So 0 plus 1 is 1, which is incremented by the value of B, which will again place 1 in the A. So if you observe here, when you keep iterating through the while loop, the value of A remains unchanged at 1 here. Therefore, this we will never come out of the while loop. This will be a infinite loop. It is a infinite loop and the program shall not terminate. The program shall not terminate. Sorry. The program shall not terminate. Let us see one more question from the C programming. Let us see one more question from the C programming. So we are given this function int f, which takes two arguments, int x comma int y. Int x comma int y, and in this function we have a for loop which iterates from 0 till y, which iterates from 0 till y, and each time you are assigning x plus y to x. At the end you are returning the x value. So we are given four options here. We need to choose the right answers. So option A, x value is 20, y value is 10, and they are saying the return value shall be less than 2 raised to the power of 10. Option B, they are saying if the x value is 20 and y value is 20, then the return value will be greater than 2 raised to the power of 20. Option C, so again x value is 20, y value is 10, then the return value shall be greater than 2 raised to the power of 20. Similarly, option D, when the x value is 10 and y value is 20, the return value shall be greater than 2 raised to the power of 20. So these are the options given to us. So we need to choose the correct answer. So now observe here what is happening in the loop. in the for loop, what we are doing essentially here, so we are doing 2x plus y assignment into x, right? X is being assigned 2x plus y, right? So if I write this loop mathematically, so what am I actually doing here? So for how many times? For y times, the iterator I, it is running from 0 until y. That means for y times, I am doing this assignment x equal to 2x plus y. So let us see what it is. So in the first iteration, what will happen? X is assigned 2x plus y. In the second iteration, what will happen? X will become, this is the current value of x, right? So multiply it by 2 and add y. So we get 2 into 2, that is 4x, and here 2 into y, that is 2y plus y, that is 4x plus 3y. And in the third iteration, we multiply this current value of x with 2 and add one more y here. So you can see 2 into 4, 8x plus 2 into 3, 6y plus y, that is 7y. So you can make out the pattern here, right? So for the iteration k, what you will have? 2 raised to k into x plus 2 raised to k minus 1 into y. So take 2 raised to 2 raised to k, you can take common, so you will get x plus y minus y, right? 2 raised to k into x plus y minus y. So now we know that this for loop is running for how many iterations? Y number of iterations. So what is the final return value that you will get here? Return value is equal to 2 power y into x plus y minus y. The program returns 2 power y into x plus y minus y. Now see which of the options are satisfying. So if x is 20 and y is 10, then what will be return value? Return value will be 2 power 10 into 20 plus 10, 30. This is a very big value, and then you are subtracting just 10. So this is greater than 2 power 10. It is not less than 2 raised to the value of 10. So option A is wrong. Now let us check option B. So here the return value will be 2 raised to y, that is 2 power 20 into 20 plus 20, 40 minus 20. So obviously this value 2 raised to 20 into 40, that is greater than 2 raised to 20. So option B is a correct option. And then we have here 2 raised to 10 into 10 plus 20, 30 minus 10. So you see here they are saying the return value is greater than 2 power 20, which is false here. So we have 2 raised to 10, which is multiplied with a very small number, that is 30 here, which is less than 2 power 5 also. So there is no comparison between 2 power 15 and 2 power 20. Therefore option C is wrong. Now finally let us check here. So we have 2 power 20 into 20 plus 10, 30 minus 20. So obviously because we are multiplying 2 power 20 with 30 here, which is like near 2 power 5, right? So this is a very big value compared to 2 power 20. So option D is also a correct answer. The correct options are option B and option D. Let us proceed there is one more question based on precedence and associativity rules. So let us solve this. So we are given a precedence table like this. We are given, so plus, minus, multiply and division. So these two are high precedence operators. Multiplication is medium and this is the least precedence operator. Associativity is given like this. So left, right, right and right. Right. Using these precedence rules, we are given an expression to solve. So what is the expression here? So we have 3 plus 1 plus 5 multiplied by 2 divided by 7 plus 2 minus 4 minus 7 minus 6 by 2. Right. So here first let us see what are the highest precedence operators. So we have the highest precedence operators, addition and then multiplication. So let us try to do first the additions and multiplications. And you see here addition is left associative, therefore you will do the additions from left side. These are the additions. First let us finish them. So 3 plus 1 plus 5, this is 9. So star 2 divided by 7 plus 2 is 9 minus 4 minus 7 minus 6 by 2. So now let us do subtractions. So subtractions, they are given by right associativity. Therefore, so you start from the right side. 7 minus 6 is 1, right? So let us write this again. 4, 7 minus 6 is 1 by 2, right? So now do this one because it is coming from the right to left. So 9 star 2 divided by 9 minus 3 by 2. So finally this subtraction here, so 9 star 2 by 6 by 2, right? And after addition and subtraction we have multiplication. So let us do this multiplication. So we have 18 divided by 6 divided by 2. And finally we have division. So here we have two division operations and the associativity is from right to left. So first we do 6 by 2, that is 3, and finally 18 by 3 is 6. 18 by 3 is 6. So we will continue with more questions further.
Hello student. So now I'll be starting with DBMS. So first question of the DBMS is, consider the following schedule. Consider the following schedule S. Maybe this particular question is there. So R1 of Z, then W1 of Z, then R2 of X, then R3 of Y, then W3 of Y, W3 of Y, then R2 of Y, W2 of Y, and at last this is W2 of X, then W2 of Y. So this was the question. So which of the following schedules are conflict equivalent to the given S? Which of the following schedules are conflict equivalent to the given schedule S? Option A is given as T1 followed by T3 followed by T2. Option B is given as T1 followed by T2 followed by T3. Option C is given as T3 followed by T1 followed by T2. Option D is given as T3 followed by T2 followed by T1. Let's try to check the answer. So there are three transactions as per the given question. How would we identify? So let's try to check. So transaction T1 is there, transaction T2 is there, transaction T3 is there. So transaction T1 says that first of all R1Z, then W1Z, then next will be in another transaction. Next will be another transaction, that is what? R2 of X. Then next will be another that is R3 of Y, W3 of Y, then R2 of Y, W2 of X, and at last W2 of Y. So this is X, this is Y. Now what we need to identify? We need to identify which one will be conflict equivalent to the given schedule. So there are three transactions. So we need to create precedence graph. So precedence graph for above schedule. Precedence graph for above schedule. So T1 is there, T2 is there, and T3 is there. Now I'm going to previous slide. So it is not whenever R1Z is there, I need to check it out. In this R2Z or sorry W2Z will be there or W3Z will be there. So nothing is there. So no need to worry. Again W1Z. So R2Z or W2Z or R3Z or W3Z will be there. Nothing is there. Then R2 of X. So conflict arises due to Y only. No, and it was not in X. So R3 of Y, from R3 of Y there is W3 and W2 of Y, and from W3 of Y again there is W of Y and R2 of Y. That means what? There is a transition from T3 to T2. So there is an arc from T3 to T2. Now this will be our what? Precedence graph. Now as no cycle is there, that means what? This is conflict serializable. So this is conflict serializable. Now how would we identify? So whenever we will identify the precedence, so precedence will be given by topological ordering. So ordering will be what? The incoming age for this is what? 0. For incoming, the incoming age for this is what? 0. And the incoming age for this is what? 1. So what we need to identify? We will start with minimum incoming age. That means it can be either T1 or it can be either T3. Now T1, then we can have T3, then we can have T2, or we can write this is the only sequence. Why? Because T1 followed by T2 I cannot do. T1 followed by T2. So this will be wrong. So this can be one sequence. Another sequence is T1, T3 followed by T2 followed by T1, then T3 followed by T1 followed by T2. So T1, T3, T2, just going to previous slide. T1, T3, T2, yes, it is correct. Then T3, T1, T2, yes, it is correct. T3, T2, T1, yes, it is correct. So the correct answer for this is A, C, and D. This particular question was of type multi-select question and of marks. I hope this particular answer will be useful for you. Next, solve another question that is from functional dependency. Again, it is given in DBMS. So the question is, which of the following FD logically equivalent? Which of the following FD functional dependency is are logically equivalent? Let's try to check it out. Not equivalent, it is implied. Logically implied. So option A is given as if x derives y and y derives z, then implies x derives z. Option B says that if xy derives z and w derives y, then xw derives z. Option C says that if xy derives zw, that implies xy derives z. Option D says that if xy derives zw, then it implies x derives zw. Let's try to take it out. So we can have two methods to solve it. First, we can apply Armstrong axioms. These are simple questions with Armstrong axioms. So these are given in and these are directly related to Armstrong axioms. No need to worry about the formula. So and this particular question is of type multi-select question and for 2 marks. Let's try to check. So x derives y and y derives z, then definitely x derives z. This is called as transitivity property of Armstrong axiom. Transitivity property of Armstrong axiom. So yes, it is logically implied, or in another word, we can have the closure of x. So closure of x we can identify as what? X derives y. That means x is there, y is there, and y derives z. Yes, z is there. That means what? XZ. Yes, XZ is employed here. So we can have both ways same formula. Now XY derives Z and W derives Y. Then XW derives Z. So this is also another formula that is known as pseudo transitivity. Pseudo transitivity. In this, we can transfer the second value or not second value, that is second attribute from here. So y, we can replace this particular y with w. So what we will get? We will get w derives z. Or in another way, word we can identify simply from here xw. Let's take xw closer. So xw closer is x itself, w itself, then W derives Y, then XY derives Z. Yes, XW derives Z also. So, logically employed this also. Now, let's try to check this. XY derives ZW. That implies XY derives Z. So, this is the concept of decomposition in Armstrong axioms. So, how would we identify? Simply, uh, if AB derives CD is there, so we can write EB derives C and EB derives D. So this is the direct formula with respect to this. Again, we can identify by using closure properties. So XY closure says that what? XY closure. So X, Y, Z and W. So all are there. That means again this is logically implied. Then let's try to check option D. Option D is XY derives ZW. That implies X derives ZW. So this is wrong. Why? Let's try to check X closure. So X closure we can identify only X, not ZW. So this is wrong. So the correct answer for this question is A, B and C. Next try take another question, and that particular question let's have from group theory. The question is that is from DMGT. The question is uh, whatever I am having data from that, there are two operators, two expressions that has given A operator B that is equals to A plus 2B, and another operation is given as A square bracket B square B that is given as AB. Then we need to identify take feather. Option A says that del or angle obeys the associative law, obeys the associative law. Option B says that operator square over del or triangle obeys the distributive law. C says that operator triangle over square obeys the distributive law. And at last, option D obeys the square obeys the associative law. So as per my knowledge, whatever I am having the data, this is the question. Let's try to check it out. So now here the values are given as a triangular B and a square B. So first of all, what is associative law and what is distributive law? So associative law says that what if A plus B plus C is there, that means A plus B plus C will be there. And distributive law says that suppose operators are there. So A dot B plus C is there. So what we will get? A dot B plus A dot C. This is our distributive law. Let's try to check which particular option is correct. So now what I will get? Always remember A triangular B and A square B is this. So here again I am writing A triangular B, that is given as A plus 2B, and A square B, that is given as AB. Now what I will get? So first I need to check whether it is associative law or not. So A triangular B, triangular C, let's take this as A triangular B, triangular C. So now from first property, what I'll get? A triangular B triangular C is what? B plus 2C. Now from here, what I'll get? A plus 2 B plus 2C. From here I will get A plus 2B plus 4C. Now taking second part, so what I'll get? A plus 2B triangular C. Now A plus 2B plus C I will get. That means A plus 2B plus 2C. This is our 2C. So now this is not equal. That means what? Our first option is wrong. Now let's check other operation. That is what? A square bracket B triangular C. Okay, this is our option A. Now this is our option B. That must be equal to square A square B triangular A square C. Let's try to check whether it is correct or not. So A square B triangular C, that means again A square B triangular C is what? B plus 2C. A square, that means what? AB plus AC. From here I'll get. Now from here what I'll get? So here AB triangular AC. Now AB triangular AB triangle AC. Now again AB. So AB plus 2 AC. Yes, both are correct. That means this is correct. So this is logically employed. Now just check this particular option C. So option C is there. So let's try to check option C again. The operator is only changing. So whenever operator is only changing, that means what? Option C says that A angle B square C, that will be equal to A triangle B square A triangle C. Let's try to check it out. So A triangle B plus 2C I will get. That means what? AB plus 2AC. No. Just wait for a second. From here I will get what? A triangle BC. So from here I will get A plus 2BC. Now from here what I will get? A plus B triangle A plus 2C. Now if I'll solve it, so A plus 2B dot A plus 2C. So this is not equal to this particular part. Again, option C is what? Wrong. Next, try to solve option D. Option D says that a square b square c. Let's try to check. That will be equals to a square b square c. So this is what? A square bc. From here ab. So not I'll get and not I will identify. So from here I'll identify ABC. So again I'll identify AB square C. Now again I'll identify ABC. So both are correct. So this is what? Option D. Now previous slide. Yes, this is correct. So now from here what I'll get? I'll get option B and D both are correct. So now this is our correct answer. Next question is, how many number of spanning trees are there? The number of spanning trees are there. The number of spanning trees in a complete graph of n vertices, where n is equals to 4. This particular question is given. So there is one straightforward formula for this particular question. This question is of type numerical answer type. So straightforward formula is what? So number of spanning tree in a complete graph of n vertices is what? That is n to the power n minus 2. So here n is given as 4. So what we will get? 4 to the power 4 minus 2. That means 4 square. So 16. So the correct answer for this particular question will be 16. Next, we have another question. Let's try to check. So next question is from theory of computation. So theory of computation says that let's have two regular expressions that is given as r. R is given as 0 star plus 1 star and S is given as 0 1 star plus 1 0 star. The question says number of strings of length, the number of strings of length less than or equal to 5 which are neither in nor which are neither in nor neither in R nor in S. Okay, so is we need to identify. Now first of all R and S are there, so what we'll get? Less than or equal to 5. So first R, the strings can be 0, not 0. So 0, that means what? Epsilon 0 1 0 square 1 square 0 cube 1 cube. Then what will get? 0 to the power 4 1 to the power 4 0 to the power 5 1 to the power 5. So this is what? This is up to 5. Now S, for S what you will get? So minimum 0 or 1 0 1 1 0 0 1 square 1 0 square 0 1 cube 1 0 cube and 0 1 4 1 0 to the power 4. So these are there. Now the question says that the number of strings of length less than or equal to 5 which are not neither in R nor in S. So neither in R nor in S. This is your R, this is your S. Okay, so there are two values which are common, that is what, 0 and 1, 0 and 1. So we are keeping here. Now how many elements are there? 1 2 3 4 5 6 7 8 9 10 11. Out of 11, 2 is common, that means 9 is here. 1 2 3 4 5 6 7 8 9 10. So 8 is here. So total how many elements are there? 19. And number of strings, so what we will get? 2 to the power 6. Why 6? Because less than or equal to 5. 2 to the power 6 minus 1. So what we will get? 63. 63, out of this 63, 19 are there which are in R or which are in S or which are in both. So how many elements we are having? So total 44 which are not in R and which are not in S. So the correct answer for this particular question is 44. This particular question is of type numerical answer type and it was asked in theory of computation. Next question is, I think this question was from Chomsky normal form. Chomsky normal form. So Chomsky normal form, maybe the data I have found, the question says that for regular expression a to the power 30, b to the power 30, c to the power 30, how many number of steps required? How many number of steps required in CNF Chomsky normal form to solve the given strings, given string. Okay, so now this particular string is given to us. Okay, we need to solve. So this particular question is of type numerical answer type. Let's try to solve. So n length string is there. Then how many number of steps? So number of steps is what? Number of steps, that will be equals to 2n minus 1. Okay, so now the number of the length of the string is what? 30 plus 30 plus 90. 30 plus 30 plus 30, that is 90. So for 90, what we will get? 2 into 90 minus 1. That means what? 179. So the correct answer for this particular question is 179. Next, the question says that given as L1 and L2 are regular language and L3 is not regular language. Which of the following is our correct? Or which of the following is are true? So option A says that L1 bar union L2 bar. Option B says that, or we can say L1 complement union L2 complement. Option B says that L3 complement is not regular. Option C says that L1 is equals to L2 if L1 intersection L2 bar or L2 complement is equal to 5. And option D says that L1 intersection, L1 union L3 is not regular. Now the question says which of the following is are true. So as per data given in this particular question, we need to identify. So now L1 and L2 are regular language. So L3 is also regular. So we need to identify L1 bar union L2 bar. Yes, this is not regular. This is not regular. Again, is not regular. I think this is not regular. Yes, it is true. Now L3 bar is not regular. Yes, if this is regular, this is not regular, then its enclosure, its complement is also not regular. This is true. Then L1 intersection, L1 union L3 is not regular. Yes, it is also true. Now let's check this particular part. L1 that is equals to L2 if L1 intersection L2 bar is 5. So yes, this particular question says that there is clear cut formula. It is L1 is a subset of L2 if and only if L1 intersection L2 bar is equal to 5. Okay, so this is not matching with this, so we can have this as false. Now let's try to check in another way that L1 equals to 1, 2, 3 and L2 equals to, let's check 1, 2, 3, 4, 5, 6. Now let's have this particular L2 bar, L1 intersection L2 bar, and this is having what? This particular is having in a universal set, let's take 1 to 9. So now from this L2 bar, what we will get? 1, 2, 3, 4, 5, 6. From here we will L2 bar will get what? 7, 8, 9. Now L2 bar is 7, 8, 9 and intersection of L1 is what? 1, 2, 3. What will get? 5. Yes. So now can we say that this is equal? So no. This is what? False. So the correct answer for this question is A, B and D. You all have understood the solution. Next, let me check the question. Okay, so let's have another question that is from computer organization. Yes, consider a program that has 25% load or store instructions. Suppose ideal CPI with any without any memory stalls is 2. So given as what? 25% load or store instructions. Okay, CPI is given as 2. Then given the miss rate of instruction cache is 2%. So miss rate of instruction cache is 2% and miss rate of data cache is 8%. Miss penalty is 100 clock cycles. The speed up achieved using perfect cache with which has no miss penalty is. So this particular question is there. Now we need to identify. So a program is given to us. That program can have what? 25% load or store instruction and remaining 75% have what? Remaining 75% it has normal instructions. Now we need to identify first what instructions miss cycle. So instruction, so speed up, the formula for speed up is what? CPU time for normal cache or normal instruction on CPU time for perfect cache. So let's try to identify. So instruction miss cycle. Instruction miss cycle is what? Instruction miss cycle is given as instruction count, and miss rate is given as what? 0.02. So into 0.02 into the miss penalty is given as what? 100 clock cycles. Okay, so what I'll get? Instruction cycle. IC stands for instruction cycle, or number of instructions we can say. Okay, or number of instructions. Both are correct. Okay, now this is what? Instruction miss cycle. Now we'll identify data miss cycle. So data miss cycle. What I'll get? So instruction count into that particular data is for 25% load or store. That means what? 2.25. And how many miss penalty is there? So 0.08 into number of clock cycles for miss penalty is what? 100. What I'll get? Again, 2 instruction count. So instruction count is again same. Now total miss penalty or total miss cycle. So total miss cycle, what I'll get? So 2 instruction count plus 2 instruction count, that is for data and instruction. So what I'll get? 4 instruction count. Now with respect to CPU time for normal cache. So CPU time for normal cache is what? Ideal CPU. Okay, ideal CPU or CPI plus total miss cycle. So total miss cycle. So what I'll get? So here 2 plus 2, that is 2 plus not 2, that is 2 plus 4. So I'll get 6 instruction count. Now, so from here I'll get 6 instruction count, and CPU time for perfect cache. So CPU time for perfect cache is what? That is only ideal cache, ideal CPI. So ideal CPI. So ideal CPI is what? 2 instruction count. So what I'll get? So speed up is what? Speed up, that is given as 6 instruction count into clock cycle given to you and 2 instruction count into clock cycle given to you. So both clock cycles cancelled out, instruction count cancelled out. So 6 divided by 2, I'll get what? 3. So speed up is 3. So for this particular question, let me check. Yes, for this particular question, the correct answer is what? 3. Hope you all have understood the solution.
Okay, yes. So guys, that's all from today's session. We'll meet in next session, that is on afternoon. We'll discuss about the afternoon paper analysis at 6 p.m. So today is 10th Feb. One paper analysis and exam solution we have already completed. Okay. And the next paper, that is from 2:30 to 5:30. Just after 30 minutes of actual exam at 6 p.m. we will be live and we will have a discussion of the afternoon computer science gate 24 paper analysis as well as detailed solution. Okay guys, so stay tuned on IMS Gate Academy YouTube channel and you guys can share the session also so that other students can also get benefited. If you are looking for the computer gate 25, gate 26 preparation, then you can search IMS Gate Academy on Google. And if you are in the nearby area of Bangalore and Vijayawada, we are also providing offline classes, so you can also search. If you want to connect with the student advisory team members, you can find the mobile number as well as the free counseling session link in the description of the session. Okay guys, so thank you, bye bye, take care. That's all from today's session.